This is Calculus section 2.3, page 5. What we're going to do now is we're going to apply the intermediate value theorem. For this given function, when x is an element of values 1 to 4, including 1 to 4, k is going to equal -2. We need to find the value of c that satisfies the intermediate value theorem. We're going to sketch a graph to demonstrate what we found. So the first thing when you're trying to satisfy the intermediate value theorem, you always have to verify that the intermediate value theorem will even hold true. So the first thing we want to look at, first requirement, was that f of x is continuous. Okay, and f of x is continuous. This is a polynomial. So we're going to just write that down. F of x is continuous on the closed interval 1 to 4 because it's a polynomial. That's how we know. We know about polynomials, so we can just use that. The second piece was that the function values at a and b have to be different. So from our closed interval here, the 1 is the a value, the 4 is the b value, so closed interval from 1 to 4. So what I'll do is I'm just going to jot down f of 1 equals, and I'm just going to plug it in here, 1 squared minus 6 times 1 plus 5, and if we add that up, 1 minus 6 plus 5, that's equals 0. For b, I'm going to determine what f of 4 is, 4 squared minus 6 times 4 plus 5. Let's see if I get that. That's 16 minus 24 plus 5, so it's 21 minus 24, -3. So I figured out what the two function values were, and I can confirm that f of 1 does not equal f of 4. So that verifies that I can use the intermediate value theorem. The theorem tells us then, the third part, it tells us, since those other things are true, I have some value of c, some x value of c, that I can plug into the function, and I will get the value k. In this case, they gave us the value of k as -2, and we have to find out what the value c is. So we were given that this is -2. We're going to plug it in. We're working with c, so we're going to plug that in to the original equation. So back up here, f of c is going to be c squared minus 6 times c plus 5, and that has to equal k, which is -2. Alright, now all I need to do is solve for c. So I'm trying to find what c value satisfies this theorem. I'm going to add 2 to both sides, so I get c squared minus 6c plus 7 equals 0. And now I can factor that. Actually, this one does not factor. This does not factor. So you can use the quadratic formula. You can use your calculator. You could graph that and find out where the zeros are. If you use a quadratic formula, you remember this. C equals opposite b plus or minus square root b squared minus 4ac all over 2a. I'm going to leave that to you to do, whether you do that on the calculator or the quadratic formula. And you actually get two values for c. C equals 1.585. Remember to always round to 3 decimal places. And c may also equal 4.414. So sometimes there are two possible answers, but before you move on and say these are the answers, we need to check the interval. Remember the interval was closed from 1 to 4. This value is in the interval. This is not in the interval. So we actually want to exclude that. Because remember the value of c needs to fall in that closed interval from 1 to 4. That one does. At this point we need to graph the result. Sketch a graph to demonstrate this information. So we'll start with, it's a parabola opening upward. We do have a couple of points already. We know that at 1 the y value is 0, and at 4 the y value is -3. And actually, we could, put another couple of points on the graph that basically it's looking like this. So we have 1 here, we have 4 here. Remember, this is our closed interval. So the only part of the graph that we're interested in is this part of the graph from here to here. Our point 4.414 falls out here, so I'm not worried about that particular value. The value of k that we were targeting was -2. So we can show our point 1.585 approximately here corresponds to a y value of -2. So f of c, when c equals 1.585, equals k, -2.